Greetings, time travelers. Today, we embark on an awe-inspiring expedition through the annals of prehistory. Get ready to have your beliefs challenged as we uncover the top 10 scientific discoveries that reshape our understanding of the ancient world. From unexpected fossils to mind-boggling artifacts, this countdown will take you on a thrilling adventure through time. Welcome to the RobotRay channel. Discovery number 10. Aquatic Dinosaurs. Scientific discoveries challenging prehistoric beliefs have reshaped our understanding of dinosaurs, and one notable example is the realization that certain dinosaurs were adapted to aquatic environments. Traditional views often portrayed dinosaurs solely as land-dwelling creatures, but recent findings have unveiled evidence supporting the idea that some dinosaurs were semi-aquatic or aquatic. Fossils of dinosaurs like Spinosaurus, for instance, suggest adaptations such as elongated crocodile-like snouts and paddle-like limbs, indicating their proficiency in aquatic habitats. This challenges the long-standing notion of dinosaurs as exclusively terrestrial beings and highlights the diverse ecological niches they occupied during the Mesozoic era. The aquatic dinosaur discoveries prompt a re-evaluation of the prehistoric landscape, suggesting that various dinosaur species exhibited a wide range of adaptations to different environments. This revelation challenges the once conventional depiction of dinosaurs confined to terrestrial realms and underscores the complexity and diversity of these ancient creatures' lifestyles. As paleontologists continue to unearth new fossils and analyze existing evidence, our understanding of prehistoric life evolves, challenging and expanding upon previously held beliefs about the habits and habitats of dinosaurs. Discovery number 9. Feathered dinosaurs. One of the most groundbreaking scientific discoveries challenging prehistoric beliefs involves the presence of feathers on certain dinosaur species. Traditional depictions portrayed dinosaurs with scaly, reptilian skin, but fossil evidence has revealed that many dinosaurs, particularly within the theropod group, had feathers. The discovery of well-preserved fossils in regions like Liaoning, China, has provided remarkable insights into the plumage of dinosaurs such as velociraptors and Tyrannosaurus rex relatives. These findings challenge the long-held notion of dinosaurs as exclusively scaly reptiles and instead suggest that feathers were a common and essential feature for many species, possibly serving functions like insulation, display, or even aiding in flight for some smaller dinosaurs. Feathered dinosaur discoveries have not only transformed our understanding of dinosaur anatomy but also triggered a re-evaluation of their relationship to modern birds. The evidence of feathers on certain dinosaur groups supports the theory of avian evolution, suggesting that birds are direct descendants of feathered dinosaurs. This profound revelation blurs the once distinct line between birds and dinosaurs, emphasizing the dynamic and interconnected nature of Earth's evolutionary history. The recognition of feathers in various dinosaur species challenges preconceived notions about the appearance and behavior of these ancient creatures, providing a more nuanced and avian-inclusive perspective on the dinosaurian world. Discovery number 8. Prehistoric Art. Scientific discoveries challenging prehistoric beliefs have expanded our understanding of early human cultures, particularly through the revelation of prehistoric art. Traditionally, there was a perception that symbolic and artistic expression emerged relatively late in human history. However, archaeological findings, such as cave paintings and engraved artifacts, have pushed back the timeline of artistic creation to much earlier periods. Discoveries like those in the caves of Lascaux in France and Altamira in Spain showcase intricate paintings dating back tens of thousands of years, suggesting that our ancestors had a sophisticated capacity for symbolic representation and artistic expression far earlier than previously thought. These prehistoric artworks challenge the notion of a linear progression of human cognitive development and reveal the rich cultural and cognitive diversity of ancient societies. The discovery of prehistoric art provides valuable insights into the lives, beliefs, and cultural practices of early human communities. The intricate details and symbolic nature of the artwork hint at a complex society with a capacity for abstract thought and shared cultural meanings. This challenges the notion that early humans were primarily focused on survival and suggests a deeper, more nuanced understanding of their intellectual and cultural capacities. Prehistoric art discoveries have become a crucial lens through which we explore the cognitive and cultural dimensions of our ancient ancestors, challenging preconceived notions about the timeline and sophistication of early human societies. Discovery number 7. Human ancestors. Scientific discoveries in the field of paleoanthropology have significantly challenged prehistoric beliefs about the evolutionary timeline and relationships among human ancestors. Advances in fossil discoveries, DNA analysis, and comparative anatomy have reshaped our understanding of human evolution. For instance, the identification of Homo naledi in South Africa challenged previous assumptions about the complexity of burial practices, suggesting that a primitive hominin species may have intentionally disposed of their dead in a ritualistic manner. Additionally, the revelation of the Denisovans, an ancient human population known from DNA extracted in Siberia, has expanded the genetic tapestry of human evolution, indicating that multiple hominin species coexisted and interbred in ways previously unknown. The discovery of new hominin species and the revelation of interbreeding events challenge the simplistic linear progression of human evolution once depicted in early models. These findings emphasize the complex web of interactions among different human species, highlighting periods of coexistence, adaptation, and genetic exchange. By challenging preconceived notions, these discoveries contribute to a more nuanced and dynamic narrative of human evolution, showcasing the intricate interplay of genetics, culture, and environmental factors in shaping the diverse array of hominins that have existed throughout prehistory. Discovery number 6. Advanced tool use. Scientific discoveries challenging prehistoric beliefs about tool use have revealed the advanced capabilities of our ancient ancestors. Traditional views once portrayed early hominins as simplistic tool users, but archaeological findings have unveiled evidence of sophisticated toolmaking and usage much earlier in human history. For instance, the discovery of tools at the site of Dmanisi in Georgia suggests that Homo erectus, an early hominin species, was capable of crafting stone tools with intricate designs and multiple functions. These findings challenge the notion that only later Homo species, such as Neanderthals and Homo sapiens, exhibited advanced tool behaviors. Advanced tool use is not limited to Homo species alone. Evidence from other hominin lineages, such as the Australopithecines, also challenges preconceived ideas about early toolmaking capabilities. Discoveries at sites like Sterkfontein and Swartkrans in South Africa indicate that Australopithecus robustus, a distant relative of modern humans, used tools for processing and extracting resources. These findings collectively challenge the linear progression of tool complexity in human evolution, highlighting that advanced tool use was an integral part of the behavioral repertoire of various hominin species throughout prehistory. Discovery number 5. Ancient civilizations. Scientific discoveries challenging prehistoric beliefs about ancient civilizations have been pivotal in reshaping our understanding of early human societies. Traditionally, there was a perception that complex, organized civilizations only emerged relatively recently in human history. However, archaeological findings, such as those at Göbekli Tepe in Turkey, have challenged this view by revealing the existence of sophisticated monumental structures dating back over 10,000 years. Göbekli Tepe predates the advent of agriculture, challenging the conventional narrative that advanced civilizations were exclusively linked to settled agricultural communities. This discovery suggests that complex social structures and monumental architecture were present in hunter-gatherer societies, challenging preconceived notions about the prerequisites for advanced civilization. The discovery of ancient civilizations like the Indus Valley Civilization also challenges previous beliefs about the earliest urban societies. The well-planned cities of Harappa and Mohenjo-Daro, with advanced drainage systems and standardized bricks, thrived around 4,000 years ago. Their existence challenges the Eurocentric bias in early civilization studies and emphasizes the global nature of human cultural development. These discoveries collectively challenge traditional timelines and assumptions about the prerequisites for complex societies, expanding our appreciation for the diverse and sophisticated cultures that flourished in prehistoric times. Discovery number 4. Extinct megafauna. Scientific discoveries challenging prehistoric beliefs about extinct megafauna have revealed a more complex narrative surrounding the extinction events that shaped Earth's ancient ecosystems. Traditional views often attributed the demise of megafauna, such as mammoths and saber-toothed cats, solely to climatic changes or overhunting by early humans. However, ongoing research suggests that a combination of factors, including climate fluctuations and human activities, played roles in the extinction of these large creatures. For example, evidence from various sites worldwide indicates that some megafauna persisted for longer than previously thought, challenging the simplistic notion of a sudden and uniform extinction event. Additionally, discoveries such as the presence of human tools associated with megafauna raise questions about the extent of human impact on these ancient ecosystems. While climate undoubtedly played a role, the interactions between humans and megafauna were likely more nuanced, involving factors such as habitat disruption and competition for resources. These findings challenge preconceived ideas about the causes of megafauna extinctions and underscore the importance of considering multiple variables in unraveling the complex dynamics that led to the decline of these magnificent creatures in prehistoric times. Discovery number 3. Prehistoric DNA. Scientific discoveries related to prehistoric DNA have been instrumental in challenging and reshaping our understanding of human evolution and ancient populations. Advances in DNA extraction and sequencing technologies have enabled researchers to analyze ancient genetic material, providing unprecedented insights into the relationships between different human populations and our evolutionary history. One significant discovery involves the identification of archaic hominin DNA in the genomes of modern humans, pointing to interbreeding events between Homo sapiens and now extinct hominin species such as Neanderthals and Denisovans. This challenges the once prevailing view of a linear and isolated evolutionary path for Homo sapiens, emphasizing the intricate web of genetic interactions among different hominin groups. Furthermore, the analysis of ancient DNA has revealed unexpected population movements and connections in prehistory. Studies on ancient genomes have illuminated migration patterns, such as the surprising genetic ties between individuals in far-flung regions. For example, the movement of people during the Bronze Age has been traced through genetic data, challenging previous assumptions about the insularity of ancient societies. Prehistoric DNA research is revolutionizing our understanding of human prehistory, providing a molecular-level perspective on our ancient ancestors and challenging long-held beliefs about human migration, interbreeding, and the interconnectedness of diverse populations across time. Discovery number 2. Prehistoric climate change. Scientific discoveries related to prehistoric climate change have challenged earlier beliefs about the stability of Earth's climate throughout ancient times. Traditional perspectives often depicted prehistoric climates as relatively stable over extended periods. However, evidence derived from ice cores, sediment layers, and other geological records has provided insights into the dynamic and sometimes rapid shifts in climate that occurred during prehistoric epochs. For instance, the study of ice cores from Greenland and Antarctica has unveiled detailed records of past climate conditions, revealing abrupt temperature changes, shifts in atmospheric composition, and fluctuations in sea levels. These findings challenge the notion of prehistoric climate stability and emphasize the Earth's susceptibility to significant environmental changes. Additionally, the analysis of fossilized flora and fauna, as well as pollen records from sediment layers, has contributed to understanding the impact of prehistoric climate changes on ecosystems. The discovery of past warm periods and ice ages, as well as fluctuations in precipitation patterns, has challenged earlier assumptions about the constancy of environmental conditions. These scientific revelations highlight the complex interplay of natural factors that have shaped Earth's climate over millions of years, challenging preconceived notions and informing our understanding of the potential impacts of current and future climate changes. Discovery number 1. Origins of life. Scientific discoveries challenging prehistoric beliefs about the origins of life have transformed our understanding of the fundamental processes that led to the emergence of living organisms on Earth. Traditional views often centered around the idea that life originated in a specific location or during a specific period. However, ongoing research into extremophiles, organisms that thrive in extreme environments, has challenged this notion. Discoveries of life in extreme conditions, such as deep-sea hydrothermal vents or acidic hot springs, suggest that life may have emerged in a variety of environments, challenging the idea of a singular and narrowly defined primordial soup. Furthermore, the discovery of organic molecules, including amino acids and complex compounds, in celestial bodies such as comets and asteroids challenges the Earth-centric perspective of life's origins. These extraterrestrial organic molecules provide evidence that the building blocks of life may have been delivered to Earth through celestial processes, challenging preconceived notions about the isolation of life's origins to our planet. These discoveries collectively push the boundaries of our understanding of life's beginnings, inviting a broader exploration of the conditions and mechanisms that led to the emergence of life in the vast expanse of the cosmos. And there you have it, time travelers, the top 10 scientific discoveries that challenge our beliefs about the prehistoric age. Each finding opens new doors of understanding and invites us to question what we thought we knew about our ancient world. Join me for more mind-expanding adventures and captivating discoveries on the RobotRay channel. If you found this video fascinating and informative, don't forget to give it a thumbs up and subscribe to RobotRay channel for more incredible explorations. Thanks for watching, and until next time, keep on exploring.